And I'm on a roll.
Welcome to Extending Your Data Center to the Edge with Insight Principal Architect Andrew Nelson and Insight Field Architect Daren Westman.
Welcome to our web presentation on the intelligent edge. This topic is bringing the data center technology out to the edge. It's going to have an infrastructure focus to the discussion around IoT architectures. I'm Andrew Nelson, Principal Architect with Insight, and I'm joined by Daren Westman. Do you want to introduce yourself, Daren?
Sure. Daren Westman here, Cloud Solution Architect, and happy to be here.
So we're going to be talking about an intelligent edge end-to-end architecture in this session. It's really how do you operationalize efficiently an end-to-end IoT architecture. We're not going to be talking about how to do a POC, POV, proof of value, proof of concept pilots. We've got other sessions done by some of our peers on those topics. This is very much an infrastructure focus and very much an operational operating an infrastructure at scale for IoT. So this is what we believe the intelligent edge should be to be able to operate at scale based on our experiences in the field. Needs to be resilient, scalable, extensible, secure, and most importantly, operationally efficient. The resilient piece of it is important because a lot of IoT pilots and proof of concepts are done with entry level or commodity gear or available gear, things like Raspberry Pis and such. They work fine for a pilot. They tend not to work fine in the long haul. So we're going to talk about some of the devices and technology used to make an IoT offering resilient. And that can mean different things. It can mean redundancy. It can mean environmental functionality of the device. Sometimes they're hardened and waterproof and so on and so forth. We also believe that IoT architectures need to be scalable. Most of our IoT pilots that we've done with customers and implementations start out small. They start out with one use case or two use cases, but very quickly clients recognize all the value that these architectures can bring to the business, and all of a sudden we are doubling and tripling bandwidth and storage and compute and so on and so forth. So we're going to talk about how to make your IoT architecture scalable. Extensible is important as well, in about the same context. We are seeing a proliferation of GPUs and AI at the edge and specific protocols and interfaces for devices. And the extensibility is important. You can't put an NVIDIA or an AMD GPU into a Raspberry Pi very easily, for example. And then we're going to have a theme throughout this whole presentation around security. Daren and I were just talking a couple days ago. There were IoT security articles popping up left and right. There was a casino that was just breached through a fish tank thermometer just yesterday. And last week they were talking about security concerns in IoT devices. That security is super important at every layer of this architecture. And Daren, do you want to touch on, when we talk about operationally efficient, some of the things that we're thinking about here?
Yeah, absolutely, Andy. And I mean, when we really think about it operationally efficient, this area is still so, it's the wild, wild west still. And really thinking about how do we manage all of these devices, as we scale into thousands of devices far beyond the POC and POV. Really, how are you going to communicate? How are you going to push updates? How are you going to secure them? Are you going to allow them to push updates? Are you going to pull updates? How are you going to be communicating with these devices? So the management and the monitoring aspect at scale is really important, just as all of these particular topics are. But this one is absolutely one to talk about too.
And you have to keep that into consideration when you're thinking about your overall business value you're driving. The ROI of these solutions melts away really quickly if you've got two guys in a truck having to drive out to do this manually at thousands of sites across the country or across the globe.
No doubt.
So we've got a couple slides here on kind of who and why, and we're not going to dwell on these topics in very much detail. There's a couple other sessions that you can download that talk about in much more detail why IoT is very important to different retail and different verticals. You're also going to see the details of the journey and how to build ROI and TCO and go through a pilot. We're assuming at this point in our talk that you've you as a client have thought through we're interested in IoT, we've done a pilot, we've come up with a couple use cases. Now we want to figure out how to scale this and do this in an enterprise or a robust fashion. This is a topic that's near and dear to my heart. I come from a utility background before I worked as an integrator. I used to run a SCADA system, which is really old school code for IoT. If anybody's worked in manufacturing or power generation or oil and gas, those industries have done what we call IoT today for decades. It's SCADA, it's industrial automation, industrial IoT is a new version of that. And the only real difference is we're using more commodity gear and we're using commodity protocols. Now, what's changed in the last few years is other industries have figured out how to monetize these technologies, monetize these solutions, and get tangible business value out of them. Daren, do you want to touch on maybe some of the other industries we have here? The sky's the limit in this conversation.
It sure is, Andy. And I mean, if I think about the last year with the pandemic and trying to keep employees safe in the workplace and having everybody return, I mean, we're hearing a lot about as employees are entering and taking temperatures, and in fact, Insight is involved in this area with several companies, as well as like things like retail. Right, we start looking at um, heat maps in a particular location and where are customers going. Right, this data is so important. And the other one that comes to mind is when we start thinking about stadiums and what the crowd is looking at and paying attention. Right, one of the more recent ones that I learned about, in fact, is they would put ads up on the large screen, and they would have these cameras looking out at the crowd, and they would key up how long are they looking at the screen, and they would take all this data so they knew advertisements specifically what interests the crowd. So I think it's really interesting, and it's sky's the limit, to your point.
Yeah, and the real takeaway from this conversation is that if you're an industry that has any sort of data with any sort of value, IoT could be the answer to unlocking that for your enterprise or your business. So why the intelligent edge? We've talked about this a little bit. Like I said, other sessions are going to dive into it more. Daren touched on a few of these, but it drives operational efficiencies. We're seeing that the clients that have IoT enabled and monetized have a huge advantage in operational efficiencies and in losses. We're seeing this with security. We're seeing this with employee safety. We're seeing this with warehouse tracking. That's a big differentiator from an operational perspective. We also see in retail, Daren mentioned retail briefly, but retail vendors that have that extra client information, they can extract more information around buying patterns. A good example that a lot of us are probably familiar with is somebody like Target. If you're standing in an aisle at Target, and they're not even necessarily doing this with IoT in the past, if you text one of those codes that they have on the freezer doors, they're actually knowing that you're standing in front of that freezer door and can send you targeted coupons and targeted discounts. And we're seeing that morph into heat map tracking, facial recognition, and heat map tracking in between the different aisles, so that a retailer can see that, wow, he's standing in front of the Snickers bar a little bit longer. If I send him a Snickers coupon, he probably will buy it. Something along those lines. Daren, you want to talk about maybe the security and the safety aspects of this too?
I just think this particular all these industries and consuming this data, and I think to the simplest to the most technical, when you get into different industries, whether it's in the warehouse and tracking, whether it's safety or how things are being done, or even training employees, this data is it's so valuable.
So that's a perfect segue into this next slide. So if we've got a data set that is very valuable, like Daren just said, and has tangible business ROI, we can't live without it. And if you've operationalized it and monetized it, having outages and having transport issues and having to spend a lot of time maintaining the infrastructure becomes very, very challenging in these architectures. So the rest of this conversation is going to be around how do you build this architecture to scale and be operationally efficient. This specific slide is some of the bullets that we have around how to deploy an edge architecture at scale. We believe that the physical platform needs to be robust and appropriate. The key word here is appropriate for the remote locations. I totally can reuse an old desktop or an old laptop as a gateway device for IoT. It will work. It won't work well if it's in a hostile environment, or if it's next to a fat fryer in a fast food restaurant, or if it's on a shop floor with metal particulates. There are very appropriate hardware devices in the field that can be used for different environments. So that's probably the biggest takeaway: is make sure you use the right tool for the job, and specifically with the environment and temperature controls. We also believe that there's a software platform that needs to be efficient operationally and portable. We don't want a software platform that locks us into a specific device. We may end up having multiple generations of devices in an IoT landscape. That's probably another key takeaway for the traditional IT folks: is IoT life cycles aren't going to be that 3 to 5 years that we're used to in the data center. It's going to be a 5 to 10 years or longer, depending on the usefulness of the gear. So we want to make sure that we have a software platform that can process it efficiently and also be life cycled and be portable. The sensors are important too. This is kind of our joke that we made earlier about the fish tank thermometer that was hacked at a casino. Sensors are totally the wild, wild west. There are tons of different things to choose from, with varying degrees of robustness, varying degrees of support, varying degrees of protocol support. And again, picking the right sensors for the job when you roll out your IoT architecture is important. Don't misinterpret what I'm saying here. For POCs, pilots, for proof of concepts, we're totally cool with using entry-level, commodity, inexpensive sensors to prove a business case. But when we're going to roll out hundreds of thousands of them across thousands of sites, you really want to think through how do they get updates? How are they maintained? How robust are they? Am I going to be replacing them all the time? Sensors become very important. And we've seen this in anybody that's done security cameras at scale. Security cameras are all over the map. You can get some for $30 and some for thousands of dollars. And there's a huge difference in how robust they are and how they're managed. And then we're going to beat this one to death: security, 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 and security. Make sure that we have a secure transport out to the edge. Don't rely on application security by itself. I'm not going to dwell on the details of this box, because we've got our networking peers doing a session in parallel with this on all of the network plumbing to make a secure network architecture. Just know that you need to make sure that the network is secure, as well as the applications that ride on top of it.
Andy, I think you hit on some really good points here for the edge. And I know that we've seen this with many customers as we begin having those conversations, and we talk to the customer, they're like, sure, we're doing this and this, with our IoT. And then we start talking about, well, how are they being accessed? How are they updated? And all of these things that you talked about, whether it's the correct physical hardware and whether or not it's resilient and its rigor and it's going to last, all the way down to the software aspects. Is it wide open to the world? Is it going over a VPN? Is it is it going over an SD-WAN? I know we'll talk about those things, but so many of these things are huge topics that we discuss with customers every day.
Well, and this topic is the backend processing cloud core. You can use whatever term you'd like to use here. Daren, do you want to talk through some of the challenges we have on the backend core architecture?
Yeah, absolutely. I mean, so first off, let's just start with when a customer is first engaging, and we start talking about putting together a POC, a proof of concept, right? We absolutely focus on driving the core, the back end of this into the cloud. And that means a public cloud provider, right? So you can name it AWS, Azure, so forth, right? It doesn't necessarily mean that it's the perfect fit for the production solution. It really depends on what the customer use case is, where they're located, how they're connected. There's so many variables, but the point being here is, start off small, start off with that OpEx model when you're into the POC. Maybe it's starting with that smaller gear. I know we'll talk a little bit more about that, But then as you drive into, final deliverables into production, it's really important where it lands, the storage of the data. And we start talking about the software platform of ingesting the remote data sets from, the edge. All of these things are super important. I think the number one thing here, Andy, and you and I have talked about this, is the flexibility to scale up and scale down, right? I mean, this is key. And I'll kick that back over to you on some examples, right? I mean, this is a big topic.
Well, scale up absolutely, because we see with most of our IoT rollouts, the use cases start to blossom, and before you know it, you start out scanning a thermometer or scanning a simple sensor with a simple data set, and all of a sudden we're adding video and thermal cameras, and the data footprint scales incredibly. But we also see in certain industries the ability to shrink. So in retail, we may have a lot less foot traffic for half the year. And so maybe that analysis of heat map tracking is much less. Or a good example is a lot of sporting venues and sporting leagues. They go from 100 to 0 overnight in the off season. Stadiums can be empty for weeks. Well, and COVID's proved this times 10. But the stadiums can be empty for long periods of time. So in those industries, you really want to architect to be able to shrink, and that's a little bit harder to do with brick and mortar infrastructure. So this is a good conversation to have as you're moving out of the POC pilot phase into how do I want to roll this out for the long haul? Do I want to stay in the cloud so that I can grow and shrink? Can I monetize it better in a data center? Maybe it's a hybrid architecture with a little of both, and that all depends on your use cases and the industry that you're in. So this is also a conversation around the WAN. So again, we're not going to belabor this point a ton because there's a separate session on all the WAN technology. But again, we're going to plug the fact that your network transport needs to be secure. We've actually been involved in some IoT rollouts where the answer to security is the app is simply just an SSL tunnel. Well, okay, great. That might be fine for that one app, but later on, if other apps or other functionality or other protocols get used, are you going to be guaranteed that they're encrypted as well in transport? And so we believe that you should have encryption at every level that you can. That's sort of the PCI stance. If there's technology that's readily available, you should implement it. That's really our stance on network security. The connectivity that's flexible is huge. So most IoT rollouts, one size fits all from a network transport isn't going to work. Retailers tend to be in different markets, different locations, may have different connectivity options. Anybody that's in an industrial or a utility space is going to be in rural areas that may not have any hardwired capabilities. I'm based in Texas, so you get a lot of oil rigs out in the Gulf that have satellite is really their only option. And so that flexible connectivity in your architecture is important, but you want to have a layer over the top of it to make it so that you don't have to manage all of that complexity. So this is starting to be the poster child for an SD-WAN-like solution. And I'm not going to say that SD-WAN is the only way to do this, but a lot of our SD-WAN or SASE solutions tend to abstract all the network complexity. They tend to allow you to scale and add bandwidth on demand. They allow you to merge multiple transports together. That's as far as we're going to go on this slide. I would urge you to go sit in on my network peers. They're doing a whole session dedicated to all of this network security and network plumbing. But that's also super important in these rollouts. Again, past a pilot. For a pilot, use what you have. But after that, you should be thinking through now, how do I make this network robust, flexible, and scalable?
Yeah, I know you and I have talked a little bit about this, Andy, but depending on what's happening out at the edge and how much data really needs to be sent back, how reliant you are on that core. And I know that we'll show some architectures and have a discussion about that, but gosh, this is an area and it's a big area. So that's why we're really referring you over to this other session because this is its own topic.
Yeah, we could spend hours talking about just the network. Don't tell the network guys that, though. So this section is an illustration of the templates and recipes or reference designs that we've built. So our team has actually gone and built an end-to-end architecture with a couple different software vendors and with a bunch of our hardware partners. And this is an illustration of the design assumptions that we bring to this conversation. So we're going to go through edge requirements and then an edge architecture and core and so on and so forth. So this is our disclaimer slide that we've been dancing around already. For proof of concept and proof of value pilots, use whatever term you want. You can kind of sort of ignore some of what we're going to talk about. I'm a firm believer in fail fast, and this is an example of that. So if we're piloting some IoT use case, go scrounge an old desktop that you've got laying around, use the existing network. Don't invest a ton of money until you've been able to prove the use case. So we see a lot of these, and we've got a lot of pilots that we've done with customers with a whole fleet of Raspberry Pis. They're an awesome device for this kind of exercise. Same thing with networking. Use what you have if you can get away with it. If it meets the bare bones needs for the pilot, go for it. The core side, the last bullet on the right, I'm a firm believer that the public cloud should be used always, almost always, if not always in this case, because I can spin up an environment, I can spin up the backend software, I can use GPU if I need it, and I can do it all with a swipe of a credit card. I can use it for a month or two, prove value, and then decide where I want to take it after that. That could, like Daren said, be the end all be all for our architecture, or we could find out, wow, we can monetize this better in a colo or in an existing data center or an existing remote facility. This is just a disclaimer slide saying that what we're going to talk about from here on out is all about how to do this at scale in an enterprise operational mindset rather than a proof of concept or a proof of value. So edge requirements. The first bullet here is a big one for me specifically. So I believe, and we believe, that you must have out-of-band management on the remote devices. There's a big struggle right now in operationally IoT in patching and life cycling and upgrading. We've got tons of clients that have done an IoT rollout, had great success, and 6 months to a year in, are like, now I've got to upgrade because of some security exploit, or I've got to go from Ubuntu 18.04 to 20.04, or pick your favorite analogy. But to do that remotely can be challenging because anybody that's worked in the data center knows that without out-of-band management, we've got to go cable up a keyboard and a mouse to a device every so often. This is a big differentiator. Almost all the vendor partners that we work with have somewhat hardened devices at the edge that have some sort of ILO, DRAC, SIMC, pick your favorite algorithm or your acronym, but they're all out of band management so that I can get onto the console, I can reboot it, cycle power remotely, all that kind of stuff. That's probably the biggest one that separates the Raspberry Pi-like architectures from an enterprise. The other one is the next couple are pretty easy. We should be able to do Linux on the box. Most of the IoT edge architectures want a lightweight operating system. So it's some form of Linux and some form of Kubernetes or a container architecture, something like Docker. We're actually seeing embedded Linux and K3, if you're not familiar with that moniker, that's a single file Kubernetes that we'll talk about before. It's a really lightweight Kubernetes deployment, and those are becoming huge. The next few design requirements are things that we are taking into consideration. So I know not all IoT deployments are going to be in hostile environments, but we are architecting such that they're going to be in hostile or semi-hostile or at least non-condition space. Even most retailers don't have a lot of condition space out at remote stores. If you as a client are lucky enough to have full data centers at every location, awesome, you can use data center class gear. But most of the stuff we're talking about here needs to be able to handle particulates or handle lack of HVAC or humidity or so on and so forth. We also should be able to store and forward data. We need to architect so that if the connectivity is at all remiss, we aren't losing data. Same conversation as before. If we've proven that this data is valuable and useful to the business, I shouldn't have huge gaps in my data sets. So I'm using a kind of a financial term, store and forward. We'll also hear resilient queuing. There's a bunch of different terms for this in the industry. In a nutshell, though, the box has to have appropriate local storage. And that could be an SD card, or it could be a RAID controller with a bunch of disk in it. It all depends on how much data and how long and how important it is to the business. And then we also should be able to do some limited GPU or video processing. And this is for AI and for video. In our architecture, we are architecting to this. I'm not saying every device needs to be able to do this, but we're seeing a huge influx of video into IoT and GPU processing out at the edge. Video workloads don't transfer very well across to WAN. So sometimes doing some light analysis out at the edge can be really important. And you're going to see this as a theme through the rest of our discussion.
Andy, I just want to take a moment and kind of double click a little bit on, I think, the key bullet out of this slide, and that's that out of band management, right?
Mhm.
Because when we work with customers, they don't always plan for once the device is in the field and hey, it's going to be stable. Sure, the software may be stable, the hardware may be stable, but I guarantee you, and we've seen this, that at some point somebody has to go and physically do something. And this is really a big gap that we're seeing out there in the field. And
Yeah. So this is the pets versus cattle discussion that we
totally,
talk about all the time, is that the traditional data center guys treated all their assets like pets, cared for them, patched them, fed them. Um, This isn't quite a cattle example, though. IoT at scale, you want to think that you can let the cattle roam free for years and not pay attention to their health. But the analogy that I use is this is more like a dairy farm. If you've seen how dairy cattle are taken care of, they show up in the barn a couple times a day to be milked. They tend to have RFID now on the dairy cattle to be able to give them appropriate medicine, to adjust their feed based on their milk production. IoT is much more analogous to that. We're not going to care for our assets like we would care for data center assets, but we need to be able to do some of this out of band management like we've historically done or not done in the data center. And that's the challenge with these architectures for sure.
yeah, I mean, think about putting something up on a pole somewhere, right? A camera or a sensor, right? And at some point, it's got to be replaced or it needs to be rebooted. How's it going to be done, right? It's in the middle of nowhere. So the two guys in a truck analogy is perfect.
Yeah, and you have to think through. We frequently get asked, well, that device that has out of band management costs me, $200 more or $300 more. Well, great, but that trip with two guys in a truck costs you way more than $200-300 in the grand scheme of things. You just have to think that way.
That's right, Andy.
So here's an example of detailed requirements, and I'm not going to go through this from a networking perspective again, because we've got another session on it, but just to touch on a few bullets here. So from a switching perspective, we want switches that have power over Ethernet, because we're going to be powering access points for wireless. We're going to be powering cameras. A lot of these new sensors have PoE capabilities if they're wired, and so I need switches that can produce and deliver that power and manage it. That's not a Best Buy class switch that you can buy. So you need to be looking at least entry-level enterprise switching. Wireless and switching need to be able to do something called microsegmentation. And this is something that we talk about with network access control, modern NAC here. I need to be able to authenticate these devices as they come from the network or the wireless. And the challenge with both of those is these devices don't have a username and a password. There's nobody sitting in front of them. So I need to be able to do a new school version of network access control. And a lot of the major networking vendors have neat functionality to be able to do authentication based on a device's vendor string and by its behavior and the protocols it used. Again, if you're interested in that, go jump into the networking session. They'll talk about it more. Another big takeaway here too is the bullet in the middle on modern IoT protocol support. Things like LoRa, BLE, Zigbee. There's a whole bunch of new wireless protocols that are entering the market, and modern access points tend to have support for them. But be careful when you're choosing access points or designing an architecture, because not all of a vendor's access points will have those hooks. And then again, to belabor the point even more, we probably want SD-WAN or something like it for our gateway firewall support. And that's modern layer 7 firewalling. That's being able to do traffic management over multiple providers and being able to do some sort of VPN-like security. So again, our network brethren will have a whole bunch more to talk about on these slides, but this is just touching on what we think needs to be there at the edge.
Yeah, I think that this is that list in your back pocket, right? And, as far as getting into the granular details of what's needed, I mean, I think at the POC, POV level, you may be able to use what you have. Maybe in some cases, the wireless side, maybe you might need to have some swaps there, especially depending on, supported protocols, feature sets, and then of course, the density of it, right? How used is that access point today versus when you start dropping in your POC, POV IoT devices and such. So
you're stealing those guys' thunder, Daren, but you're right. The density in a stadium is much different than density out in an apple orchard, right? Way different.
Yeah, absolutely.
Yeah. So what we built are recipes, templates, reference architectures. Again, I'm using those words interchangeably. We've actually got template builds of materials. We're happy to sit down and customize them to a customer's needs. But these are really starting points and approximate price points, if you will, for each of these solutions. At the edge, these solutions are not sizes as much as they are feature sets. So what we've built is a minimal footprint, which is sort of one or two of everything. There's no redundancy built in, but it's a single gateway, it's a single firewall, it's an access point or two, it's a couple small switches. This would be for a remote coffee shop or a remote retailer or a remote site that doesn't need a whole lot of wireless coverage. And kind of an entry point to an IoT architecture. The second column here is basically adapting that to be HA. So firewalls that can fail over, multiple access points, dual switches with redundancy, 2 of the compute devices. And in our designs, we're assuming that the container architecture will take care of HA. So something like a replica set coupled with a scale set in Kubernetes, for example. And then you've got HA through every aspect of this. So this is more important when we talk about things like hospitals and healthcare. So the data that you might be collecting in an IoT architecture with a hospital is much more important and critical, even from a legal perspective. So to be able to say that I'm, keeping track of video on the floor of a hospital, but because my system was down, I lost 2 days worth, that's not going to fly with a regulator. So having redundancy for data collection and stuff like that is going to drive you into that high availability. And if you've got a high value on that data that we've been talking about, the little bit of extra cost of doubling the footprint isn't probably a waste of money. The other place we see HA is in very remote locations where that 2 guys in a truck is just not an option. If you're in the middle of nowhere, sometimes it's cheaper to have a second box, a second switch, a second access point. So that's the HA reference architecture. And then the third one is a little bit more interesting because to accommodate a GPU out at a remote site generally drives you to a different platform, and video and AI processing of that on that GPU tends to drive more storage, and it tends to drive more networking. So the reference architecture on the third side is accommodating that all of those, the more local storage, being able to drive a GPU or 2 in the box, and then being able to handle a lot more throughput from both a wireless and a wired perspective.
I think the key takeaway here, right? This is all the more reason of why you would engage Insight, right? Because we'll talk and walk through your use case, and we'll fit it into the appropriate offering or solution, if you will. So I think this calls it out really nicely, and just kind of giving you that the variance in between them, and really talking through what your use case and solution may look like.
Sure. So this is very similar for the core cloud, Daren. Do you want to walk through a few of these bullets at a high level? We don't have to go through every detail on the slide, but it's the same kind of requirements we've already talked about.
Yeah, I mean, really here, just like what we've been talking about, right? When we think about compute, right, modern, scalable, right, cloud-like infrastructure, all of these things really important, just like we talked about, right? Needing to support Kubernetes, which means Linux on the kernel for the base OS, and layering it on with Kubernetes. And then, of course, we talked a little bit about the storage aspect. And I think this is one of the areas that we'll get into a little bit more in this discussion. But, how much data, what's your retention going to look like? These are pretty big decision points of maybe what the end target looks like. especially if you go into object storage. What does that look like long term? And then data protection, right? Because things fail, and you need to have that data protection in place. And then, of course, security. We hit on this already, but it's that end-to-end security. It's also looking at ingress, egress, the east-west security within the container space itself, and how it communicates, right? And then, of course, on the networking side, we talked a little bit about this, but the switching, if we're getting into the non-cloud side, what does that switching look like? What exists today? What are the requirements of this use case or use cases that you're trying to solve for? And then lastly, I think that's the firewall aspect, right? What are the feature sets? What's available, and what's current? Anything you
Yeah,
want?
and the firewalls will be dictated by the SD-WAN strategy that we've been talking about. And you're absolutely right on the storage data protection piece. Those are the two pieces that we see missed a lot. Is people didn't think through okay, I've got all this great data coming in, I'm driving all these great business decisions. How long do I hang on to it? Should I hang on to it for a year? Should I hang on to it for 10? Should I hang on to it longer? Again, if you're in the healthcare space, there can be really dramatic retentions that are imposed on some of the data depending on what it is. And data protection is a big one. We've actually had some fun with some of our IoT software partners asking them, well, how are you protecting the data? And they respond with, oh, you mean encryption? No, we mean good old fashioned backup. Like if this data has value and can be corrupted, how do we protect it? And so in our reference architectures here, we built for 30-day retention, and we've accommodated for object storage at some level, and you'll see that in the next slide. So this is a t-shirt size slide. We actually have 3 different on-premises, and what I mean by on-premises is this could be a colo, it could be a distribution site, it could be a data center, but it's where you're doing your data processing. Keep in mind too, the top of this slide talks about how public cloud is a perfect use case for the backend. Initially and eventually and potentially in the long run, depending on the economics of it. For most customers, public cloud may be the best solution for you for agility and flexibility and all the stuff we've talked about. But we've also built 3 different architectures to do this on brick and mortar hardware. All of these look like some form of hyper-converged infrastructure because that's very cloud-like. And I'm not going to necessarily go through the details of the slide. You can see that. But some of the big differentiators are the size and horsepower of the environments, the small footprint, we're expecting you're using object storage in a public cloud. We're expecting a virtual backup footprint. As we get into the medium and large, we're starting to put in a physical backup appliance or separate backup infrastructure. And then in the large, we're actually putting an option for on-premises object storage. The overall TCO of on-premises object storage in many cases is half or a third the cost of public cloud if you've got the right kind of facilities. So that's just an example of what we're doing on the core side.
I think we've found that when the object storage grows, right, it gets really expensive fast.
You
And
can.
earlier in the presentation, we talked a lot about maybe it's a seasonal location, right? And data is super heavy because you have a lot of customers or a lot of activity, right? And very quickly that object storage grows. And I think that's the one thing that customers aren't thinking of right away, right? And how quickly and how often are you going to be accessing that object storage? So does it need to be close to you? Can you put it into cold storage? Does putting it on premise make more sense long term? Those are the types of decisions. And the one thing that I did want to hit on in this particular slide is back to your initial point about AKS, GKE, and EKS, right? These are PaaS service offerings with the public cloud providers. And maybe, Andy, you can just quickly hit on the differences between what that public cloud PaaS offering is versus building it inside of your data center. What makes more sense? Is it easier? Maybe the talent aspect?
Oh yeah, for sure. So all day long, public cloud is easier. You and I can go swipe a credit card and have a Kubernetes cluster up in any one of those cloud providers in probably an hour, maybe less, and have it functional. To do this on premises involves a hardware order, it involves installation, and it involves standing up Linux and Kubernetes like you talked about. That has at least a week's worth of lead time, if not 2 or 3, depending on the way the wind is blowing. So from a time to value, public cloud, super easy to deploy and configure and get up and running. Now, from a talent perspective, a lot of people make the misnomer that in the public cloud, I don't have to manage anything. And that's not entirely true. So if I'm running on Kubernetes in the cloud, some of the Kubernetes management tasks are taken away from me, but I still have to configure services in Kubernetes, and you should need at least a rudimentary level of Kubernetes chops on up. And that's where these two solutions tend to converge, is at that Kubernetes layer. Once we've got Kubernetes running and up and operational, the interaction is very similar, but from Kubernetes on down, it can be very different. Now, on-premises may or may not be the right solution to you based on, do you own data center space? Do you have infrastructure folks? Do you have any Kubernetes talent? But with that being said, Insight does a lot of that stuff as a service in our managed services offerings as well. So don't let that sway you either way. The neat part here with the core is we can always start in the cloud and then move to an on-prem if we design things correctly in a portable fashion. And I think that's the segue to the next slide, isn't it, Daren?
Sure is, Andy.
Yeah, I feel like we built these. So the portability aspect of IoT is huge. I mentioned briefly earlier that we want to make sure that we aren't locked into specific hardware and necessarily a specific sensor or a specific camera at the edge. Because if I build in that kind of ecosystem, when those cameras go end of life, or when that vendor gets purchased or goes out of business, or we've all experienced this in IT, then it becomes a very cumbersome lift and shift. Whereas if I've architected my whole landscape to be portable at the edge, I can leverage different gateway devices and different sensors and so on and so forth. Same exact thing in the cloud. If I'm leveraging Kubernetes as my substrate, or Docker, but we're seeing Kubernetes a lot more often in this space, even though they're kind of one and the same in some fashion. Kubernetes is very portable. I can pick up a Kubernetes landscape from one location and reinstantiate it in another, and sort of pick up where I left off, especially if object storage is being used on the back end. And we're going to give you a couple examples of what this looks like with a software vendor. But this portability is huge, is not locking yourself into a specific cloud vendor and not locking yourself into a specific hardware vendor. I believe some of our digital innovation presentations that are going on talk about some of this in more detail, is how to design the whole software landscape to be portable. So I won't belabor this point too much more.
The number one thing I like about this particular solution concept is the fact that we can take all of our work efforts in that dev, POC, POV effort, and essentially there is stuff that's reusable. Now, maybe the data's not, but the point is the overall deployment concepts, it's just at scale, right? And maybe it's obviously to look a little bit different, but you're not throwing everything away.
Yep. So we're going to go through the next couple slides pretty quickly. We're going to talk now about a logical overview of what an end-to-end architecture would look like. And we're going to show you a generic logical overview with some high-level diagrams. So here's a good example of this. This is very generic. It's meant to be, but this is actually a pretty typical deployment of an IoT end-to-end architecture. You have some data processing facility we're calling the core, and then you have a bunch of edge facilities, and they can all be the same or they can be different. We've got customers that are in multiple industries that are pulling back data from different footprints. I've got a specific client in market that has oil and gas and hospitality under the same holding company, and they couldn't be more different industries, but both of them could be doing IoT in a similar landscape. And that's something we're thinking about, is in today's day with M&A, you may be accommodating different workloads. And so if you build this right, the workloads just slide right in. So the next slide here, we've got a software partner that we work with named Altair. They have an offering called SmartWorks, which is a perfect illustration of everything we've been talking about. And that's why we have it in here, is to show you an example of a software vendor that's thought through a lot of the software design architectural issues. And they have two offerings we're going to show you very briefly, a core and an edge offering. So this is what we believe the edge should look like. And I'm not going to go through all of the boxes and bullets here because we've talked about most of this already. There's two pieces that are worth mentioning that are new. So the IoT processing stack box, the fuchsia colored box at the top, that's the software vendors that we are not spending oodles of time digging into. My team at Insight are infrastructure architects. So we're basically accommodating that IoT processing stack in some fashion. We're going to show you an example of what they look like, but that's new. And then the management stack on the left, Daren and I have been briefly talking about in different slides. This is the part that's very new to these architectures. Everything else on this screen, we've done in the data center and we've done in IoT for a while. We know GPUs, we know, the compute devices, switching, all that stuff. The management stack of this, though, is becoming very different because I need to be able to manage all the network gear, the compute gear. I need to be able to lifecycle Linux. I need to be able to potentially upgrade and deploy new versions of Kubernetes, and potentially go left in this slide. I might need to be able to do some of those sensors and cameras and such. And I'm not saying that that management stack is one offering. We've got multiple vendor partners that we work with. NVIDIA's got something called Fleet Command that they're working on self-servingly because they have GPUs out in the field now that they need to lifecycle. But Rancher has got an offering in this space. The Altair vendor that we just mentioned is actually coming down from that IoT processing stack down into the container platform in Linux. You're going to see a lot of proliferation of tools in that management stack because that's what makes or breaks these architectures, is whether I can lifecycle them a year or two.
Absolutely. I think you hit the key point here. The management stack, this is the one area that has not historically had a big focus. So I love this solution and the direction we're going.
Well, and to pull on the theme, we're talking about data center experience at the edge. That management stack in the data center has been the wild, wild west too. So
Yeah.
Same difference.
No
So
kidding.
here's an example of that IoT processing stack from Altair. I'm not going to go through this in detail. I wouldn't do justice to their product. They've got a great deep dive that they can do. But the key takeaway for me here is the cute little icons that they have on all of their different containers. So all these boxes are containers. All these containers run on K3 out on an edge. So it's a really lightweight deployment. They've actually architected this to run on a Raspberry Pi-esque like box at a minimum, and it'll scale. But all of the little icons show you best of breed programming languages, things like RabbitMQ for message queuing. You're seeing a lot of tooling that's portable and open source. So the key here is portable more than open source, but I like the open source aspect too. I'm not getting locked into anything specific. And the key that you'll see here and on the next slide is they have an API server and they have a message queuing, industry standard message queuing built in, and that's how they talk to their edge. It's pretty cool. So this is the same concept in the core. Do you want to go through this one, Daren, and talk through just a couple of the differences? Again, fairly redundant. We've talked about a lot of this on this slide.
Yeah, no, we have, and I think the key here, at least in my mind, is everything IoT data processing stack below is the area that we're really focusing on. We've talked a lot about the Kubernetes aspect, the Linux aspect, even the public cloud offering and the compute perspectives. I think the big focus here, and you and I have talked a lot about this, and that's that lower or right-hand side of the slide, and that's the data protection and the object storage. Those are the areas that, we're putting kind of that magnifying glass on, if you will, to make sure that we're thinking through those, we're having the appropriate conversations, we're making considerations of what is really the requirement that's needed to be able to support something like this solution. Anything you want to add on this?
No, that's good. I mean, those are the two pieces that get missed in a lot of these architectures. I guess the other piece is we've got public cloud right next to on-premises hardware in here, and you can do one or the other or both. Hybrid architectures may be legit here. There could be a case where some of my sites backhaul to a public cloud, and I may have other sites that are not connected to the internet or loosely connected to the internet, like an oil and gas kind of situation. I may have to do something different infrastructure-wise. As long as it's Kubernetes, we don't care. And that's the punchline here, is this is Altair's backend. Same takeaway. Everything here is architected to run a container. It's Docker or Kubernetes. You can tell by their cute little icons on top. It's things like Go from a programming language. They're using Elasticsearch, but they're using open source Elasticsearch. Again, RabbitMQ. They're using Get, so they have their own Get repository. They have their own object storage, which is an open source object storage option in here. The other thing we like about this architecture is the bottom layer of this architecture is the persistent storage or storage or the containers that actually have data. So when we're talking about data protection and backups, that's the only layer I'm interested in. The rest of it is all ephemeral processing. A good example of this is in the middle of the diagram, they have an icon that says serverless. They've actually written their own functions as a service into their architecture so that you're not dependent upon a public cloud's nuances to their function as a service. Basically, I can craft a function and it gets stored into that Git repository, and then I can use that function over and over and over in the core, and they actually have functionality to push those functions out to the edge as well. Again, not going to go into a deep dive on Altair because that's a whole session unto itself, but this is an example of an all Kubernetes architecture that fits all of the boxes that we've been talking about so far. And their core is not dependent upon their edge, and their edge isn't dependent on their core. You can use them universally with an SDK.
Well said, Andy. I love it. This solution absolutely brings that best of breed solutioning. The fact that they can be broken apart and not dependent on each other. I think that was absolutely a question in my mind when I started looking at the architecture in whole end to end is like, is one dependent on the other, or are there use cases where we can just have the edge implemented and get valuable data to somebody that can take action on it?
So these last few slides, we're not going to go through in any level of detail. They're included in here for your reference. There's an example from some of our major vendor partners of the gateway specific hardware and the core specific hardware that's appropriate for what we're talking about. The reason we included this is these are product lines with most of these vendors that people are not used to. They're hardened, they may not have fans, they may run on DC power, they tend to handle different environmentals. Some of this gear can actually go below zero out in the field. And then from a data center perspective, they've all got varying degrees of hyperconverged and Kubernetes offerings. So we just wanted to show you some of the componentry that we're using in our recipes or our templates. And happy to go through any of these in detail and follow-up sessions with any of our architects. It just gives you an example of, here's some of the tooling that you can take out of the toolbox to build these architectures.
Awesome. Great session, Andy. Thank you.
Yeah, thanks, Daren. And again, call to action, reach out to your friendly neighborhood Insight account team. We're happy to have these conversations, and a lot of the pre-work has already been done on this, so it's a fairly quick conversation if you want to talk to us about how to operationalize an IoT platform.